Hi guys, in this video we are going to learn an interesting question from differential equation. Here you can see here that the question is dy by dx is equals to cot x. We need to solve this differential equation. If you are new to the Expert Tutor channel, please don't forget to subscribe it. Also, we have done many videos regarding mathematics. If you'd like to watch those, I have given the link in the description. Also, we have already done many videos regarding electrical engineering as well as mechanical engineering. If you like to watch that basic fundamental tutor videos, I have given the link in the description. Okay, without wasting our time, let's move to the question. So over here, some might already knew the answer. You can directly write the answer, but here actually we are going to take a name for this method, separable method. When you are solving the differential equation, there are many methods to solve that. So what's meant by the separable method is when you are doing another equation, when you are solving any differential equation, if there are two variables, we are going to separate those two variables and going to integrate that. That's known as separable method for differentiation. So here there are only two variables, y and x. So the part is we need to take that y in one side and x in another side. After that we are going to integrate that. That's simple. Yeah, okay, let's try that. So when we are considering about that, we can take this dy in this side and bring this dx to this next side, which is in the right side. So I'm going to write that first. So dy cot x into dx. So now we have finished the first part. After that, the second part is we are going to differentiate that. So let's write it like this: dy and integrate cot x into dx. So now we have finished the second part too. So what's the value over here? Actually, we knew that if there is no part, we can directly write it like that, 1. So because we are going to integrate this part relative to y, so we need to actually have one value. So there is no value written over here, so we can directly write it like this: 1 into dy. So here there is cot x. Most probably you already knew that how to integrate this cot x. Okay, let's move to this part, how to integrate this one. So actually we knew that actually this is known as y to the power 0. You can write it like this: y to the power 0. So here I'm going to write the integration part, which is y0 plus 1 over 0 plus 1. You don't need to waste this time here. You can directly write the integration part. It's going to be y. You can directly, if you integrate any any constant value, it's going to be the same 1. If there is 1, you are going to get y. If you're having 2, you are going to get 2y, likewise. So it's going to be y. After that, you need to integrate this part. What we can do is we can write this cot x in this form: cos x over sin x. So if you write like this, you can find a similarity using this part. You have already learned that if there is any derivative form of this lower part, let's say this is function of x and this is the derivative of this function of x. If you see any form like that part, you can directly write that ln mod of f of x plus c, any constant, any arbitrary constant. So here I'm seeing this part sin x, this is function of x, and this is the derivative of this part sin x. The derivative of sin x would be cos x, so it's going to be the derivative of this function of x. If you see any forms, not only sin and cos, you can, if you see any forms and the derivative of this lower part in the upper part, you can directly write it like this: ln f of x. Remember to put this mod sign. So it's going to be f of x here in this question is going to be sin x, so you can directly write it like that: sin x plus c. Remember, you need to write this part. C is going to be the arbitrary constant. So I hope this video would be useful for you. If you have any doubts, please comment it below. Also, we have done many videos regarding this integration. If you like to watch, I have given the link in the description, so you can always watch that. Thanks for watching.